Hello, AB Calculus. It's Monday, and today we're doing AB 2005, question number 4. If you haven't tried the problem yet, stop, do the problem, try, and then come back and look and grade. Okay? So the first part we're going to do, I'm going to try to write it big and clear for everybody, is part A. So now you can know what part we're on. Okay, so for part A, it says, for 0 through 4, find all values of which f has a relative extrema. Determine whether f has a relative min, max at each of these values. So, just to show you really quickly, what I did was I took this table. Oh, it's dark. Anyways, I took this table right here, and I made the information look a little bit more like you're used to seeing. Okay? So I took the first line that says f of 0 is -1, f of 1 is 0, f of 2 is 2, and f of 3 is 0. And I turned those into ordered pairs. I took the second line on the table about f prime x and put when f prime x was 0 or did not exist and made a sign chart, plus, plus, minus. I then took a sign chart of the second derivative and put it up here as well. Okay? So notice if something's equal to 0, it's up here. If it does not exist, it's up here, and in between the positives and negatives. We're going to use this for the whole problem. So for part A, when they say determine whether f has relative minimums or maximums, well, that's this sign chart right here. And if you look at this sign chart right here, f prime x goes increasing and then still more increasing. But then at 2, it's increasing and then decreasing, and that means that's a relative maximum. Now you might say, Mr. Pygott, it does not exist there. It can't be a max or a min. Well, the graph does exist here. If you'll notice here, it says f of 2 is 2. It's actually at an ordered pair. It's not an asymptote. And then the second thing, if you read what they say in the paragraph, they say let f be a continuous function. If you have a continuous function, then that's not an asymptote. If the first derivative does not exist, it could be because there's an asymptote, which doesn't occur here, or it could be because of a sharp turn. And the sharp turn is what does occur here. So since I already have this sign analysis chart, I will finish part A. And part A is simply that there is a relative max at x equals 2, because f prime x changes, let's just use that, changes from positive to negative values at this point. I guess I could have stopped the sentence right there. F prime x changes from positive to negative. Alright, that's part A. And now again, something new I'm trying to do is just to erase, so if you have to fast forward, you know what part we're working on. So now this is part B. Okay, for part B it says on the graph provided, graph and show all the characteristics. So if I want to graph this, the first thing I'm going to do is graph the ordered pairs. 0, -1, 1, 0, 2, 2, 3, 0. I missed 4. Well, they don't give me any other ordered pairs, but they do tell me some other stuff from here that I can use to help me. Okay, now from here to here, from 0 to 1, f prime x is positive. That means increasing. The second derivative is negative, concave down. So increasing and concave down. And then from 1 to 2, f prime x is positive, increasing. But now the second derivative is positive, concave up, increasing and concave up. Now, this right here is crucial. You might have it increasing and then increasing. This is still not perfect. Let me show you what I mean by that. You will notice f prime x at 1. Why is 1 up here? I put 1 up here. If you look at the chart, f prime 1 is 0, meaning the slope here should be 0. So it should be more like the slope is 0, where it flattens out for a moment. So we're going to flatten it out and then let it keep going. It's got to flatten. It's got to flatten out before going back up. So increasing, Slope is 0, still increasing. I did a horrible job. I was trying to draw that, but whatever. Okay, moving on from 2 to 3, it's decreasing in concave down. Decreasing concave down, and then it's decreasing in concave up. And there we go. I always call this, I always like to think of it as a, instead of a sharp turn, I call it a shark turn. Looks a little bit like a shark's fin. Wow, Mr. Pygott, that's so clever. How did you ever think of that? Because of sharks. Alright, whatever. I'm so sorry. Now we are going on to part C. Part C. Okay. Now part C, they give us some crucial information. They say g of x equals integral from 1 to x of f of t dt. And you're thinking, why, Mr. Pygott, they only gave us one piece of information. But no, they gave us 3. If you don't do this, you don't finish the problem. Remember, if they give this to you, take the derivative. So if I take the derivative, here the derivative destroys the antiderivative and x jumps in. So g prime x is f of x. And then if we take the derivative even one more time, we get g double prime x equals f prime x. Now why is this so crucial? The reason it's so crucial is g prime x is now f of x. So let's go ahead and look at all this information we had about f of x. You see all this information about f of x? This is now g prime x. And I'm actually now going to make a sign chart for g prime x. So when I say I'm making a sign chart for g prime x, I'm making a sign chart for f of x. Because g prime x is f of x. So from 0 to 4, and they say it's negative until I get to 1. At 1 it's 0, so it's negative. And then it's positive to 2, it's positive all the way till 3, and then it's negative to 4. That's crucial. Okay. And now part C says determine whether g has a relative maximum or minimum at each of the values. Well, look at 1. 1 went from decreasing to increasing. That's a relative minimum. And here, increasing to decreasing. Nice. Now I'd like to say one thing about this. Again, I made a sign chart of f of x, which we could also call g prime x. I could have made the sign chart looking at this graph. Remember, this is the graph of f of x, but now we also know it's called g prime x. What do you put on a sign chart where things are zeros? At 1 and 3, 1 and 3, and then negative values, positive values, negative values, negative, positive, negative. And remember, the negative area, positive area, negative area made my graph go down and up and down. Anyways, so here when I'm looking at this, I would say there is a relative minimum at x equals 1 because g prime x, I could call it f of x or g prime x, because g prime x changed from negative to positive. I'm running out of space. You need to write change from negative to positive values, and there's a relative minimum at x equals 3 because g prime x, which is f of x, we've already said that they're equal, changes from positive to negative values. All right, that is part C, and now let's do part D. Part D says find points of inflection. Now, points of inflection come from this sign chart, and looky, whoop, you see that right there? F prime x, well, what's another word for f prime x? F prime x is g double prime x. So this sign chart is the sign chart for g double prime x. So what would this mean? This would mean if this is g double prime x, g was concave up, concave down. That's my only point of inflection. Or remember, I could look at slopes. I could use, if this is the graph of g prime x, I can look at the slopes to make the sign chart of g double prime x. Positive slopes, negative slopes. Positive slopes, negative slopes. Anyways, part D, my only point of inflection is x equals 2 because g double prime x changes signs. Doesn't matter if it's positive to negative or negative to positive. Changes signs at these points. So it's a point of inflection. Alright. Again, hopefully this helps you, this whole part of my on A, B, C, or D. That way you can kind of skip through the part you want. And have a nice day.